Regression analysis in R is like wielding a multi-tool. It's versatile, efficient, and built for those who love digging deep into data. If you've ever worked with R, you know its power lies in its rich ecosystem of libraries and functions specifically designed for statistical modeling and visualization. Here's a closer look at how regression analysis unfolds in this powerful platform. The journey begins with data preparation. Before diving into modeling, the data needs to be in pristine condition. Using R's functions like read.csv or read.table, datasets are imported with ease. Next comes the essential task of cleaning, checking for missing values and handling outliers. Functions like summary and star come in handy to explore the structure of your dataset and identify inconsistencies. Transforming categorical variables into factors using as.factor ensures that R recognizes them correctly in the analysis. This step ensures a strong foundation for regression. Exploratory data analysis, EDA, is where the fun begins. Using visualization libraries like ggplot2, relationships between variables come to life through scatter plots, histograms, and box plots. You can spot trends, correlations, and even potential multicollinearity issues among predictors. With simple commands like core, you can compute correlation matrices, offering insights into which variables are closely related and should be used cautiously in the model. The heart of the process is model fitting. With just a single command, lm, you can fit a linear regression model in R. For instance, if you want to predict house prices based on size and location, your formula might look like this. Model LM price, size, plus location, dataset. The output from summary model provides a treasure trove of information, from coefficients and p-values to the R-squared value. This step demystifies the relationship between predictors and the target variable. But a model is only as good as its evaluation. R makes it seamless to assess performance with diagnostic plots. By using plot model, you can visualize residuals to check for normality and homoscedasticity. Residuals versus fitted plots help identify patterns or violations of assumptions, while QQ plots ensure residuals follow a normal distribution. Metrics like mean squared error, MSE, and R-squared are calculated to quantify the model's predictive accuracy. Finally, refinement and iteration complete the cycle. Based on evaluation results, adjustments might include removing insignificant predictors, adding interaction terms, or even trying polynomial regression for nonlinear relationships. R's flexibility shines here, allowing you to iterate quickly and efficiently. By the end of this process, regression analysis in R doesn't just give you a model, it provides a story of your data, backed by robust statistics and compelling visuals. It's not just about numbers, it's about crafting actionable insights that drive decision-making.